Hello, Web3Conf India. I'm really excited to be here today. I wish I could be there in person. I'm having a lot of FOMO from Goa. I see a lot of parties and stuff happening and a lot of good times being had. My schedule didn't allow me to make it out there this year, but maybe sometime in the future I would love to be there. With that being said, let me go ahead and kick off my presentation. It's going to be on an introduction to modular blockchains. So my name is Nader Dabit. I'm a developer relations engineer. I'm also an author and a teacher. I'm the founder of Developer DAO, and right now I'm working with a team and a protocol called Celestia, and that's kind of what I'm going to be talking about today, some of the work that we're doing there, and maybe why I transitioned to this team a few months ago. So I was in Goa actually about 2.5 or 3 years ago. I was there for an event called React India, and I had a really great time, and I really wanted to actually come back again this year because of how good of a time that I had. And here's are just a few pictures of me when I was in Goa. I had a really good time on the beach, hanging out, eating at some of the restaurants there. So I highly recommend, if you're just visiting there for the first time, maybe to check out some of those beach spots. They're really fun. You've probably already been there by now, maybe if you're watching this. So with that being said, what does modular blockchain mean? What does blockchain modularity mean? And how does this kind of fit in to the future of Web3? That's kind of what I want to talk about here. So a modular blockchain is essentially any blockchain that decouples the core functions of a blockchain. So the four main functions of a blockchain are execution, settlement, consensus, and data availability. So a modular blockchain is one that outsources at least one of these components. So in a modular blockchain, it might do 1, 2, 3 of these things, but not all of these things. So when we're speaking about how the architecture typically looks, most blockchains are monolithic, meaning they look like the diagram on the left where they handle execution, settlement, consensus, and data availability. Again, whereas a modular blockchain would kind of just handle a portion of these. And Celestia in particular, we only do consensus and data availability, and then we offload the settlement and execution to other layers. So what are some of the benefits of blockchain modularity? We're going to dive deep into this. So one of them, and one of the ones that interests me the most, is just around scalability. Coming from AWS, we used to have architectures, databases, and infrastructure that could handle literally hundreds of millions or tens of millions of operations per second. But when you get into decentralized infrastructure, you start realizing that that type of scale just isn't quite possible yet today. But if we want to build out the future of applications on this architecture, we need to get there. So how do we get there? And I think the approaches that we've taken up until now that have been the most widely used approaches just haven't been working. So we kind of need a paradigm shift. And I think that's kind of where the industry is headed. And this paradigm shift has a lot to do with how we architect blockchains. And modularity is a core piece of that, I believe. So let's take a look at how this scalability comes into play. So in a centralized architecture, a centralized infrastructure, scalability is fairly straightforward. How many transactions per second can our system handle and continue running at a performant pace? So if we want to scale from 10 users to 1 million users to 100 million users, does our application still continue to function and function well? But it's a lot more complicated and nuanced than that when we're talking about decentralized infrastructure or Web3 infrastructure. Because the whole idea around our infrastructure is that we need to have this data verifiability concern that we don't have to really worry about when we're dealing with a centralized architecture where we kind of trust some type of institution or some type of system to give us our architecture, and we don't really care about their verification of that data. We kind of just trust that it will be correct. But in Web3, you could think of scalability as kind of like a function or the division of transactions per second divided by the cost to validate all the transactions or the number of users validating those transactions. So in order to increase scale, in order to increase the decentralization, we want to have more people or more nodes out there that are verifying our data. So that's just something to keep in mind when we start thinking about scalability in Web3. And it's also why you often hear about certain blockchains being more centralized or more decentralized. So if you have a blockchain that only has 10 or 20 validators, or 10 or 20 nodes versus one that has thousands or tens of thousands, you will often hear people say, okay, this network is a lot more decentralized. That just means there's more nodes, there's more people verifying the data as opposed to a less number of nodes. So when we think of these nodes, there are typically two types of nodes that we have today. We have full nodes. Full nodes download and verify all of the blockchain data. They execute all the transactions and they come up with the current state of the chain. And these types of nodes are typically have a high barrier to entry, often financially, definitely when it comes to the amount of resources needed to run these. And therefore you have a minority of users that actually run these full nodes. But what you more often see are people running light nodes. Light nodes only need to download the block headers. They don't actually verify the data, but they do have a lower barrier to entry because you can actually spin up a light node fairly easily for most chains. And typically the majority of the users are going to be running these types of light nodes. But most light nodes actually have a massive trade-off. They do not offer the same security guarantees as a full node. So Celestia enables scalability not only with modularity and decoupling execution from consensus, which is something we'll dive into a lot more in just a moment, but also by introducing this idea of data availability sampling, which enables light clients to have almost the same security guarantees as full nodes. So with data availability sampling, light clients have over a 99% or can have over 99% guarantee that the entire block is valid by only downloading less than 1% of the block. And this is enabled via a technique called erasure coding. And this gives us this idea of a trust minimized light client. And with trust minimized light clients, you can increase the scalability by reducing the cost of users to operate nodes and verify the network. So users no longer need to have these massive resource requirements for running a full node. Instead, they can just run a light node and they can participate in verifying the network. And therefore, we can have a lot more people on the network verifying the transactions and the data. And another property that's unlocked that we never really had seen before is that with the scale, with the number of nodes that are on the network, the capacity also increases along with that. So that means that we can also increase the block size and therefore deal with more bandwidth and more transactions and therefore more scale on the network. So in addition to this idea of data availability sampling, let's dive into what decoupling execution from consensus means and why that might be important. So when we think about scalability, there's a lot of different things that can actually, I would say, have an effect on scalability. But one of them is this idea around execution and there being an execution bottleneck. When we think of traditional web applications, we don't think of creating a new application by, I'm going to go on my friend's server and I'm going to share that server with them and we're going to all build our application together. And then my friend's going to build an app and we're going to come on this same server and the next 1,000 people are going to come on this server. No, what we do is we spin up our own execution environment. We spin up our own virtual machine. Now, that's not how we think of execution in blockchains or how we've done so for the most part, right? Instead, we think of something like the Ethereum virtual machine where I deploy a smart contract to this shared execution environment that literally thousands or tens of thousands or hundreds of thousands of applications are all sharing along with all the users of that application. Now, that doesn't really make sense when we think of this in a end game type of situation where we want to have hundreds of millions or billions of users interacting with these protocols. So this is kind of a quick diagram of what this kind of looks like today, where everyone's deploying a smart contract to the same execution environment, and we're all sharing the same execution environment. And then you have the settlement layer, and then you have the consensus and data availability, and all this is typically kind of built on a monolithic architecture. But when we think of scalability, we've approached scalability in blockchains for the most part with this idea of vertical scaling. So we want to add more power, we want to add more resources, we want to make this machine faster and more performant. But in reality, at AWS, when we were dealing with scalability concerns, we actually approached this from two different angles. We would approach it from vertical scalability as well as horizontal. So not only would you continue to try to improve the current state of the machine and the environment that you're working in, but you would also add additional nodes and therefore have more power, more bandwidth at your disposal to scale these applications. So why don't we do that in the blockchain world? And I think that that's kind of where we're headed. That seems to be the approach. If you kind of look at the Ethereum roadmap with dank sharding and how we now have all these roll-ups that are all now going to be kind of like settling on Ethereum, we're kind of moving in that direction. If you look at Cosmos app chains, if you look at DYDX, if you look at Celestia, this is kind of the direction that we're heading. So instead of trying to throw more CPU, more RAM into a single instance, we're going to also add more instances as well. So we're going to scale in two different ways. We want vertical and horizontal scaling. So horizontal scaling is actually usually a better method because you don't get caught in this resource deficit when you now have an increase in users because you can now just throw additional hardware at it. So what this might look like in a modular architecture is that every application could have maybe its own chain or its own rollup, and then we could use something like Celestia as the consensus and data availability layer, and therefore we're able to kind of have our users operating on our execution environment, not sharing that with other users. Now this makes sense in a lot of ways, and I don't think it makes sense for every single application, but I do think that this is the direction that we're heading, and we're going to see more and more applications and more protocols taking this direction as this becomes easier. And this is one of the things that we're working towards in Celestia, and that we already have actually available that we're going to take a look at in just a moment. You also have this idea of specialization at each layer. When you separate these layers and you're not focused on doing everything, you can focus on doing one thing right. So therefore, when you think of how we are only focused on data availability and consensus, you can have more efficient resource pricing and a lot of other things that you wouldn't have if we were trying to kind of handle settlements and execution as well. You also have more flexibility. So when we think of deploying an application today, you're often tied into a single execution environment for a specific blockchain. So if I'm building on Solana, I'm writing Rust and I'm dealing with Anchor. If I'm deploying on Ethereum, I'm writing Solidity or maybe Viper. If I'm building on something like a zero knowledge rollup, you might have your own different language and area that you're working in. But what if we could experiment and play around with different virtual machines, and we could deploy them all just as easily, and we didn't have to kind of be tied into a single execution environment or a single virtual machine. That's one benefit, I think, because this idea would enable developers to deploy their own app chain regardless of the virtual machine or execution environment that you're working in, and also fork and change and play around with other virtual machines as well. And again, this kind of, I would say, has a lot to do with flexibility, but also experimentation. So let's say that there's a VM that I like, but I want to change a couple things about it. I can maybe fork that code base, make those changes, and then I can use that. So we're not kind of like stuck and tied into a single implementation of an execution environment. We can instead play around with different ones and experiment and maybe improve and share the work that we've done as well. So one idea would be, custom execution environments. This would typically be either by creating one from scratch, which is kind of a heavy lift, but maybe more likely forking existing execution environments and making updates. But we do see already modular execution environments like Fuel that are being worked on that are really interesting, that are made specifically for modular blockchains. Another benefit is this idea of sovereignty. So when we think of a blockchain today, we are essentially like sharing a chain when we're like working with something like the EVM or Ethereum, I guess you could say, in the sense that we're launching our application, but we're sharing the settlement layer, we're sharing the forking and all of the different changes that happen within that community with our own application. So if something big happens, we kind of have to go along with that. We don't really have any say so. If our protocol gets hacked and something wild happens, there's probably zero chance we're going to convince the rest of the Ethereum ecosystem to fork Ethereum just to save something in our own application. But in a sovereign world, you're actually able to do that because you control the future of the chain. You control the forkability of that, and you have full control. So when you think of rollups or blockchains on Celestia, they're essentially self-sovereign blockchains because you're not having to share a settlement layer with another application. You have full control over everything. And this is really important because in certain situations, this is what you want. And this is, I think, a reason why DYDX went with Cosmos, because there's a few other reasons there as well, but they probably wanted to have more sovereignty over their ecosystem and their community and the future of what they were doing and more control. So what are sovereign chains? What are some characteristics of sovereign chains? They share full security with each other. Each chain doesn't need its own validator set, so it's easy to deploy without having to kind of bootstrap your own security and your own validator set as well. And it's very similar actually to Cosmos, which really innovated, I think, in this space. And the main difference is that you do not have to split a validator set. And also in the future, you will have more flexibility on the different execution environments. So with Cosmos, you can deploy Cosmos SDK. Today, you also have, I think, Evmos. But in the future with Celestia, you'll also be able to have probably more execution environments like Fuel, even maybe Aptos and Sui and Move and stuff like that as well. Every app and community can frictionlessly have their own sovereign community computer without being burdened by design decisions of another community or institution, according to their own top-level social contract and without having to bootstrap their own security from scratch. So one great tweet that I saw, if you know anything about Cosmos, is that Celestia's vision is a marriage of Cosmos sovereign interoperability zones and a roll-up-centric Ethereum with shared security. So a quick look, though, at Celestia consensus, just for people that might be curious. Celestia implements tendermint consensus, and we don't actually reason about the validity of the transaction. So literally anyone can post data to the chain. As long as they pay the fees, we accept order and we replicate that. The actual validity rules, like are these transactions valid, are actually left up to the settlement and the execution layers to figure out. So we only allow the data to be saved, and we, again, kind of like order that. And then the execution layers are the ones that are having to deal with the validity rules and execution of that data. So what does it look like to build on Celestia? There's a couple of different ways that you'll be able to build. You can start building today, and we're going to look at that in just a moment. And in the future, we're going to have a lot more ways to build. So one is deploying to a rollup or L2 already running on Celestia. So this will probably be the lowest barrier to entry. This will mean something like I have forked Optimism and deployed it to Celestia, and then you can deploy a smart contract to that. And that's kind of going to be one way that people are going to be building on Celestia. You're going to see Fuel deployed, I believe, at some point. Fuel will allow you to deploy a smart contract there. And this will look a lot like just deploying a smart contract today, where you are sharing the execution environment. And you're also kind of benefiting from some of the scalability properties as well. You can deploy a rollup to a settlement layer running on Celestia. So Celestia will have, again, data availability and consensus, and then other people will deploy specialized settlement layers that people can deploy rollups to. So once that is available, you'll start being able to deploy your own rollup. And in the future, we want to make it as easy as deploying a smart contract as it would be to deploy your own rollup. And that's kind of like, the future that we're working towards. Another way would be to actually work with Ethereum and use Ethereum as a settlement layer and Celestia as the data availability. And with this, we have a word that we've kind of like set aside to kind of describe this category of application. It's a Celestium. So a Celestium allows you to kind of do this. We have smart contracts that are already built out, and we're going to begin testing these soon on testnet for people to start playing around with this. And then finally, deploying a sovereign chain. And that's kind of a lot of the use cases that I've talked about so far today. So just being able to deploy your own app-specific rollup or your own app-specific chain to Celestia. This is already available today with Cosmos SDK. In the future, it will be available for other different virtual machines. So what are some of the configurations that you can build with this stack? I'm going to take a look at some of the existing Ethereum-centric modular stacks, or the Ethereum-centric stacks that start incorporating modularity, and then we're going to look at Celestia. So the traditional monolithic approach of Ethereum was that it had everything in a single execution environment. Everything, along with the execution environment, would be settlement, consensus, and data availability all together. And we've started moving away from this. We've started seeing that we have now more roll-ups and side chains. This is kind of where most people deploy their applications, I believe, today. So you have things like Optimism, Arbitrum, Polygon, Arbitrum Nova, all of these different new execution environments that essentially like roll up or bundle transactions to Ethereum. You also have this idea of a Validium, where you kind of do the data availability off chain. So an example of this that is somewhat in this category, just recently released with Reddit, was with Arbitrum Nova. I don't believe they're actually true Validium, but they kind of are having this off-chain data availability and their own execution environment. So it's kind of taking a similar approach. With Celestia, you can use Ethereum if you would like, or you can kind of work in these other different ways. So we talked about Ethereum being used with Celestia as a Celestium. A sovereign rollup would look more like this, where you kind of have your own application, your own chain that does the execution and settlement, and then you kind of leverage the layer of Celestia for data availability and consensus. You might have this idea of leveraging a settlement rollup, where you deploy your own execution environment to a settlement rollup like Sevmos, which is something that we're working on. But we'll see, I think, other examples of this, where Sevmos or another settlement rollup will be deployed on Celestia, and you can deploy your own chain to that rollup. And then there's the Celestium, which we talked about already, where you deploy your application to Celestia using Ethereum as a settlement layer and Celestia is the data availability layer. So this is a diagram that we put together recently to kind of show some different areas that would be available for kind of like the future of what this is going to look like. So for execution, you might think of forking something like Optimism. You'll see Fuel and Arbitrum, probably types of different forks, or these chains actually deployed themselves possibly to Celestia. For execution. For settlement, you might see something like obviously Ethereum with Celestiums. We're working on something that we're going to be open sourcing, or maybe it's already open source, called Sevmos, which will be a settlement layer. And I think we're going to see a lot more settlement layers like built specifically for Celestia. For consensus, you have Celestia, Ethereum, and then Polygon has something called Avail, which is similar to what we're doing here at Celestia. And then for data availability, there's a couple of examples there. I haven't really looked too much into ZK Porter or StarkX, but you're starting to see more and more teams kind of building with this modularity in mind. One of the pieces of software that we've released that enable developers to start building in this way is called Optiment. It's a drop-in replacement for Tendermint, and it allows you to build a Cosmos chain very easily. And instead of doing the Cosmos BFT consensus, it actually dumps the blocks onto Celestia. And this is a really easy way for you to deploy a Cosmos SDK chain as a sovereign rollup on Celestia. And this is actually really easy to get up and running with. You can go to our docs at docs.celestia.org to kind of get started with this, but you can actually build a sovereign chain on Celestia with the Cosmos SDK, and really just like 5 different commands from your command line. You can scaffold one and kind of have it ready to go to deploy. So you would use the Ignite CLI to scaffold out a new Cosmos SDK blockchain, and then you would just change the Tendermint for a Celestia by running a single command here. And then you could start actually running and deploying, or running and sending transactions to Celestia right away, actually. So with just a couple of lines of code, this could kind of get you up and running. So if you want to learn more about Celestia, I would check out celestia.org/learn. I would also check out this blog post called Roll-Ups of Sovereign Chains by one of our co-founders, Mustafa. I would also check out this podcast interview with Mustafa called Modular Blockchains for Sovereign Communities with hacktivist Mustafa Al-Bassam. And I would say also check out Build Modular on the celestia.org and maybe follow me also if you're looking to learn more about this. So that's it for my presentation. I appreciate you checking this out. I hope you enjoyed Web3Conf India, and I hope to see you there next year and actually be there in person. So thank you so much for having me here. It's been an honor, and I hope to see you all again next year. Thank you.